Quick question. Do you know how many AI models are out there right now? Well, according to Hugging Face, there are over 3 million publicly available models out there. And let's say you chose a model that you really like, you go to their Hugging Face page, you try to download it, and there's like 9 different quantizations, 4 different parameter sizes, and no indication on whether any of that will actually run on your particular machine. Ideally, you would want to know if this model is going to throw an out-of-memory error on you before you download the full 8 gigabytes. So how do you decide which one to use? Well, luckily there is a tool for that now. It's called llmfit, and it looks at your actual hardware, your GPU, your RAM, your CPU, and then it tells you out of hundreds of models which ones will genuinely run well on your machine and how well will they perform. And as you can see here, I got a bunch of different devices on the table. So in this video, we're gonna take a look at llmfit, see how it works, and then I'm gonna test it out on a bunch of these machines and see which models fit each of them. It's gonna be a lot of fun, so let's dive into it. Now at its core, llmfit is just a simple terminal tool. You run one command and then it detects your system, your CPU cores, RAM, and GPU, including multi-GPU setups. And then it scores your setup against a bunch of available models from their database. And not only that, but it also gives you an indication how many tokens per second you can expect on your local setup when running this particular model. And of course, to properly estimate your hardware capabilities, it uses the best tools for the job, depending on your GPU cards and your infrastructure. Plus, it also evaluates if you have any acceleration backend installed on your machine. And it also tries to estimate the best quantization level of that particular model based on your hardware requirements. And each model is scored against 4 criteria: quality, speed, fit, and context. And then those get combined into a composite score. But the way they are weighted against each other isn't always fixed. So for example, chat cares more about speed, while reasoning weighs quality much higher. So the same model can rank differently depending on what you're actually trying to do with it. But how does llmfit actually determine those speed numbers? Well, the way it works is that every token means reading the entire model's weights off your VRAM once. So speed really comes down to how fast your VRAM can feed the GPU. llmfit identifies the real memory bandwidth from your specific card, so it takes that number and then runs it against the model size to estimate how many tokens per second you'll actually get. And if you want to get into the weeds of all that, there's also an advanced config panel where you can tune all of that yourself. And they added that after someone on GitHub pointed out that token per second estimates were coming in too high for certain models. And if you have some other GPU that is not in the bandwidth table, it falls back to per backend constants: CUDA, Metal, ROCm, and so on. So you're never left with a zero estimate, you might just get a slightly less precise one. And one more cool thing is that they have a community leaderboard where you can check performance results from real users using the same hardware as you, so you can actually compare it against a practical benchmark and not a theoretical one. Alright, this tool sounds great, so I want to test it out on a bunch of different devices because I'm really curious what kind of models can you actually run on older devices. So we're going to start with this first gen Raspberry Pi, and this thing is from 2012. Single core, 700 megahertz and 512 megabytes of RAM. A couple of months ago, I did a video where I successfully deployed a 19 million parameter model on it, so let's see if llmfit will suggest something similar in our test. So a couple of things actually happened here. First, it did run, but it was so painfully slow. This board just doesn't have the horsepower to run a Rust 2E comfortably. But anyway, let's look at the recommendations, and they are genuinely hilarious. First of all, it recommends DeepSeek R1 as the best choice with almost 400 billion parameters. And that would take 230 gigabytes of disk space, but at least it's being honest when calculating tokens per second, putting it at only 0.8, and the memory percentage needed for this thing is Also bonkers. Now, as I said, I did test out this board before running a model called Falcon H1 Mini, so I tried to search up the same model and see if it's in the database, and it actually is there, but oddly enough, it only gives us a score of 51 compared to the enormous DeepSeek R1. And this is the funniest part. It says that it can reach 241 tokens per second. Now, in my original video, it clocked around 0.3 tokens per second, so this is what, 800 times more than that? So obviously something is wrong here, and I guess for boards as old as this one, it just can't calculate a realistic candidate, which is fair. I didn't even think this app would run on a Raspberry Pi at all, so I'm not too concerned about that. Now we're going to move on to a Luckfox Pico Ultra W. This is not even really a computer in the normal sense. It's a tiny embedded board built for camera modules, security systems, that kind of thing. But it does have Linux on it, and it's single core Cortex A7, 256 megabytes of RAM. So since this Luckfox board comes with a specific Linux version pre-installed on it, I could just SSH into it from my MacBook and run llmfit remotely. And here we see something similar to the Raspberry Pi board. It recommends the same DeepSeek R1 model with 400 billion parameters, and it sets the same score. So I'm not sure. I feel like this app is just not meant to calculate model recommendations for such small development boards. Next, we're gonna test it on a 2015 13-inch MacBook Pro, 8 gigs of DDR3 RAM, Intel Core i5. This is actually the first one in the list that is a real computer people use to do real work on. So I'm curious whether it will find anything worth running at all, or if this is still gonna be a dead end. So as expected, this is the first machine where the lineup of recommendations actually starts looking quite usable. So now we get a list full of small models that are all flagged as being good. So that's a great sign. Mostly all of them are quantized down to 8 bits, estimated anywhere from 40 to 170 tokens per second, depending on the model. But, you know, to be honest, I think this is too generous of an estimate. I don't actually think Llama 3 could reach that high of a token count on such an old 2050 MacBook. But I don't know, let me know in the comments down below if you've actually tested a model like Llama 3 on such an old MacBook. And another cool thing you can do in this tool is to filter down use cases to check if there are any good coding models, for example. And when I strip that down, we get the best recommendation being Qwen 3.6 with 12 billion parameters and 2-bit quantization. Although I'm not too happy about 2.3 tokens a second, but I guess that's a trade-off you're making for running 12 billion parameters on such an old laptop. Next, we're going to test it on my M2 Max MacBook Pro with 32 gigabytes of unified memory, and this is where things should start looking a lot more normal. It has real GPU cores and real memory bandwidth, and llmfit actually understands Apple Silicon properly, so I want to see what it recommends here and how close the speed estimate comes to what I actually get normally. So on my M2 MacBook, as we can see, the best recommendation is DeepSeek R1, although I'm not sure what kind of model this is. It says DeepSeek R1, but it also has Qwen tied to it. So I'm not sure, is this some kind of a symbiotic model of some sorts? But judging by this tool, I guess this is the best case scenario for my MacBook. But once again, if we filter down, looking specifically at the best coding model, we can see the Gemma 4 12 billion version comes out on top. And I actually do agree, because I recently did a video on this model and it was a beast, especially on MLX setups. So I do agree with that result. And finally, I'll test it on my beefiest machine, the RTX 5090, 64 gigabytes of DDR5 RAM, Intel Core Ultra 9, 285K. This is the one where I actually expect llmfit to start recommending the big models. So let's see what it thinks I can get away with. So on my beefy machine, I get a bunch of recommendations for different Qwen 3.8 versions. And as you can see, this time I'm getting a perfect score on almost all of them. So there's plenty of models to choose from. And amongst all the Qwen versions, we also get Gemma 4 12 billion version. But here I also want to filter out to see what are the best coding models. And even with this filter, I'm still getting a bunch of Qwen 3 models. But then if I sort it by context size, we can see that there's actually Kimi K 2.7 D-Flash version, which was released by NVIDIA. So that is really interesting. And this is something closer to the actual model that I would choose for this specific task. Not trying to be harsh on Qwen, but I'm gonna be honest, I'm not a biggest fan of their models. So Kimi K 2.7 would probably be a better pick, in my opinion, based on these. So there you have it, folks. That is llmfit in a nutshell. I think nowadays, when there are so many AI models to choose from out there, we tend to get in an analysis paralysis mode. So it's nice that there are some tools out there that can at least make this task of choosing the right AI model a bit easier for us. So what do you folks think about this tool? Have you tried it? Will you use it? Let us know in the comment section down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video. And also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.